Hello guys and welcome back to CEBox tutorial channel. So ngayon naman, nasa situation 4 na tayo ng structural engineering and construction. Okay, so kinuha rin namin ulit ito sa nakaraang CE board noong May 2015. Pero before tayo mag-solve ng ating problem, so kung nagustuhan ninyo at marami rin natutunan sa ating situation 1, 2, 3, so please subscribe and hit the bell icon for the notifications and updates on our YouTube channel. So this is our situation number 4. The truss shown is made of Guijo. The truss supports a vertical load P is equivalent to 20 kN at C. Given the following allowable stresses for the grade: wood, compression parallel to grain is 13.2 megapascal, compression perpendicular to grain 4.3 megapascal, and shear parallel to grain is 2.32 megapascal. So number 1, what is the axial stress of member AC? Number 2, what is the minimum value of X? Ito yung ating X. And what is the minimum value of Y? And okay, so nakalagay rito allowable stresses, no? So if we say allowable stresses, ito lamang yung allowed na stress na pwedeng carry, okay, ng isang member. So meron naman siya mga iba't ibang condition. Sabi rito, linawin lang namin kapag sinabi kasing grain, yung wood grain, ito yung direction ng natural niya. So, yung mga guhit-guhit sa wood, yun yung tinatawag natin na wood grain. So sabi rito, yung compression parallel to the grain, okay, kuwari ito yung grain natin. Yan. So, yung compression stress niya na parallel lamang dito sa ating grain, ang stress na yon or allowable stress na yon is 13.2. Yun namang compression stress na perpendicular sa grain natin, ayan, naka 90 degrees sa ating grain, that is 4.3 megapascal. And the shear stress parallel to the grain is 2.32 megapascal. So, ang unang pinapahanap yung axial stress. Wala naman tayong problema sa axial stress, hindi ba? Kasi kapag sinabi natin axial stress, this is normal. Normal to the cross-sectional area. What I mean is, yung ating force or stress is perpendicular or normal to sa ating cross-sectional area. So, saan nga bang cross-sectional area ng ating member AC? Andito siya. Diba? Nandyan yung kanyang cross-sectional area. So, observe natin yung problem or yung ating figure. Kasi nakalagay rito, yung height daw ng ating wood member or wooden member is 150. And nakalagay rito, 150 by 100. Therefore, yung ating cross-sectional area dyan ngayon is ganito. Yan. Okay? So, ito yung 100. So, naka-base siya. Then, ito yung height or depth na 150. So, ang gagamitin natin area para doon sa axial stress ng member AC is ito. Kung babalikan natin ang stress sa ating strength of materials under chapter 1, yung mga stresses na kung saan ang first topic natin is yung normal stress, ang ating normal stress is equivalent to P over A. Na kung saan yung ating P nga is perpendicular doon sa ating cross-sectional area. So, ibig sabihin, para masolve natin ang axial stress, kailangan natin ng P. Ito ba yun? No. Yung P nga is perpendicular sa ating cross-sectional area. So, since ito yung ating cross-sectional area, ang hahanapin natin dyan is yung P na ito. Okay? Or sabihin natin AC na lang. Ayan. AC. Ito yung tinatawag natin na internal force AC. And ito naman yung ating internal force BC. So as you can see here in our figure, kung 30 degrees to, wala na rin binigay na angle dito di ba? Kasi obvious naman sa drawing na siya ay symmetrical. So ibig sabihin, 30 degrees din to. So kung symmetrical sila, ibig sabihin, ang ating AC at BC ay equal sa isa't isa. So, ibig sabihin, pwede na tayong summation of forces vertical dito sa point C using method of joint para makuha yung ating AC or BC. Okay? So, By summation of forces, vertical is equivalent to 0. Upward is positive. Downward ang P, so therefore it is negative 20 kilonewton. Okay? Then upward ang AC. Di ba ang AC inclined yan? So ito yung kailangan natin, yung vertical component niya. So, pakita na rin natin yung yung vertical and horizontal component. Okay? So kailangan na natin yung vertical. So plus kasi positive, plus or positive kasi upward. So plus AC. Then multiplied by sine of 30 degrees para ma-convert siya into vertical component. Then dalawa. Bakit siya dalawa? Kasi equal lang ang AC and BC. So, yun ang kailangan natin. Okay? Then, equivalent to 0. So, makukuha natin ang AC. So, negative 20 plus AC sine of 30 degrees multiplied by 2 is equivalent to 0. So, 20. So, 20 kilonewton ng AC. Ibig sabihin, ang ating ring BC is equivalent to 20 kilonewton. And kung mapapansin nyo, compression yung ating AC, di ba, and BC. Kasi papalapit siya sa ating, kasi kapag kinat natin yan, okay, magiging ganito yung ating yan. Okay? Magiging ganyan yung ating free body diagram. Ito yung grain. So, ibig sabihin, ang ating AC is compression. Yan. Okay. So ngayon, kung compression to, compression din yung BC. So masolve na natin yung ating axial stress. So number 1, axial stress for AC is equivalent to P AC over the cross-sectional area sa AC. So this is 20 kilonewton, no? So ang gusto natin makuha is megapascal. So gawin natin itong newton. So this is 20 times 10 raised to 3. And this is newton over area. Ang area natin is 150 multiplied by 100. Kung millimeters to, therefore this is millimeter squared. And newton per millimeter is megapascal. So 20 times 10 raised to 3 over 150 multiplied by 100. So this is 1.333. So 1.32 ang sagot. So malapit pa rin sa answer natin. 1.33 megapascal. So kung ang given man sa mga choices is merong type of force or type of stress, kung compression man yan or tensile, so tingnan nyo na lamang kung anong type of force tayo. So since ang ating AC is compressive force, therefore this is compressive stress. So ito yung sagot sa ating question number 1. Number 2. What is the minimum value of X? Nasaan ba ang X? Diba andito yung X? Ayan. Ngayon, since nakuha na natin ang ating internal force sa AC at ito ay compression yan, ang AC natin is 20 kilonewton. So, ibig sabihin, itong 20 kilonewton na to is merong effect dito sa connection na yan. So ngayon, ang tanong, ano ba ang mangyayari dun sa section na kung saan tinutukoy natin yung X? So kung X yan, ang mangyayari dyan is, or kapag pinersa natin ito, yung ating member AC papunta rito, okay, ang mangyayari dun sa X is shear. Okay, mag-i-slide. Ayan, mag-i-slide yung ating wooden member. So kung mag-i-slide yan, magkakaroon tayo ng shearing. Okay, so kung shearing, ang gagamitin natin is yung shear stress na parallel do sa ating grain. So ngayon, ang cross-sectional area nito is ganito. Ayan. So ito yung X. Tapos, ito naman is 100 millimeters. Bakit? Kasi yung height nga natin is 150. So, ayan. 150 by 100. So, ang height natin is 150. Ang base naman natin is yung 100. So, ang cross-sectional area natin is ito. Okay. So, gamitin natin yun sa next page. Under tayo dito sa Number 2, minimum X. So kapag sinabi natin minimum X, magagaling lamang yan sa allowed or allowable stress. Okay? So ang ating area dito is equivalent to 100 multiplied by X. Kung shearing to, ibig sabihin tau is equivalent to shear force over shear area. And ang ating shear area nga is 100 multiplied by X. So kung meron tayong allowable shear stress na ilan yun? 2.32, ang tanong na lang is ano yung ating shear force. So based dito sa ating drawing, diba dito yung ating area? Diyan nangyari yung shearing. Okay? So ngayon, based dito, ano yung force na magkukos ng shear stress dun sa area na to? Eh diba, ito yung ating AC na 20 kN. Hindi naman siya magkukos ng shear dyan. So ngayon, kapag kinonvert natin yung ating AC ng kanyang components na vertical and horizontal, makikita natin dito na yung kanyang horizontal force ang magkakos ng shearing or shear stress dito sa area na yan. Okay? So, ibig sabihin, kailangan natin i-convert yung 20 kN into horizontal component. If this is 30 degrees, therefore, this is 20 cosine of 30 degrees. Kaya, yung ating shear force na V is equivalent to 20 cosine of 30 degrees. Kaya makukuha na natin yung ating shear area. The shear area is equivalent to V na 20 cosine of 30 degrees over shear stress na 2.32. So that is megapascal, hindi ba? So that is Newton per millimeter squared. Ito, kilonewton. So convert natin into Newton para mag-cancel out yung Newton at ang matira na lamang ay millimeter squared. So, ang ating shear stress is over 2.32. I mean, shear area 7465.74. So, 7465.74 millimeter squared. So, makukuha na natin ng X. X is equivalent to AB divided by 100. So, divide lang natin ito ng 100. So, 74.657. So, 74.657 millimeters. So, that is the answer. 75 millimeters. Number 3, what is the minimum value of Y? So, isolve natin yung Y. Okay, yun yung requirements natin sa number 3. So, solve for the minimum value of Y. So, check natin dito sa figure na to kung anong area yung involve ang Y. So, check natin. Okay, so mula rito, andito yung area kung saan involve yung Y. So, syempre, compressive yan. I mean, compression yung i-carry nitong area na to. Eh kaso, ang given lang kasi natin dito is compression parallel to grain and compression perpendicular to grain. Yes, hindi natin pwedeng gamitin itong shear. Kasi, mapapansin natin, yung ating Y, or yung area na to, na involve yung Y, is under sa compressive stress. So, dun lang tayo sa dalawa. Kaso nga, ang nakalagay lang kasi rito is parallel and perpendicular. Eh, paano ba yung ating wood? Naka-incline siya. Okay? So, naka-incline. Hindi naman, or yung ating grain kasi is hindi directly perpendicular or parallel sa ating Y. So, anong gagawin natin? So, gagamitin natin yung concept ni Hankinson's. So, gamitin natin yung Hankinson's formula. So, ano nga bang sinasabi ng Hankinson's formula? So, for a wood that has uniaxial compressive strength, okay, so, okay tayo dito sa una. Bakit? Kasi, uniaxial compressive strength, under sa compression yung ating area na to, hindi ba? So, okay tayo dyan. Ang sabi niya rito, for a wood that has uniaxial compressive strength of sigma sub O, which is parallel to the grain, and sigma 90 which is perpendicular to the grain. Okay? So, ibig sabihin, yung area daw na to, or section na to, na merong uniaxial compressive strength na kung saan meron tayong stress na parallel sa grain and at the same time perpendicular sa grain. So, okay na naman tayo dyan. The Hankinson's equation predicts that the uniaxial compressive strength of the wood in the direction at an angle alpha to the grain is given by, so meron tayong alpha. Ating alpha is yung 30 degrees. So ito yung equation na gagamitin natin. Ibig sabihin, kailangan natin kunin yung stress with respect to angle alpha. Okay? So ito yun. Ating sigma or stress with respect to angle alpha is equivalent to the stress or the compressive stress parallel to the grain multiplied by the compressive stress perpendicular to the grain over the compressive stress parallel to the grain multiplied by sine squared of alpha plus the compressive stress perpendicular to the grain multiplied by cosine squared alpha. So, yun ang gagamitin natin. Okay? So, stress for the 30 degrees is equivalent to stress na parallel. Ano ba ang parallel? 13.2. Then, perpendicular is 4.3. So, 13.2 multiplied by 4.3 megapascal over, okay, ito, yung ating parallel, that is 13.2. Then, sine squared of 30 degrees. Then, plus perpendicular na 4.3 multiplied by cosine squared of 30 degrees. Kaya makukuha natin yung ating stress with respect to angle alpha. So, 13.2 multiplied by 4.3 over 13.2 sine squared theta or sine squared 30 degrees plus 4.3 multiplied by cosine squared of 30 degrees. So, 8.699. 8.699 megapascal. And syempre, ito yung gagamitin natin na stress para makuha yung area na to. So, syempre, compressive stress pa rin to. Sigma is equivalent to P over A pa rin. Na kung saan, ang ating P is yung 20 cosine of 30 degrees. Hindi natin pwedeng gamitin yung vertical component kasi ang ano niyan ang i-cost niya dun sa area na to is shearing, hindi ba? So, ang rules kasi dito is compressive strength. So, dapat 20 cosine 30 degrees kasi siya yung mag-cost ng compression sa area na to. Okay? Then, ang ating area dito is equivalent to Y. Then, multiplied by, kung drawing natin yung ating area, ito na yan. O, dito na lang. Okay? Yan. Ito na yung ating area. So, ang height natin is yung Y. Then, yung ating base is, siyempre, ito height to 150. So, ang base natin is 100. So, multiplied by 100. Okay, so makukuha na natin yung A. Ang A natin is equivalent to P na 20 multiplied by 10 raised to 3 cosine of 30 over the stress na 8.699. So this is 199 or 1991, okay? 0.09. 1991.09 millimeter squared. So therefore, ang ating Y is equivalent to, divide lang natin ng 100, so 19.911 millimeters. Yan. Okay. So actually, wala kaming ganitong discussion itong concept ng Hankinson's formula sa sa strength of materials siguro to, I think. Okay, sa strength of materials. So, wala kami. So, sorry kung wala kayong mapapanood about sa concept kung paano ito na-derive. Pero anyway, diniscuss naman namin kung saang condition lamang natin pwedeng gamitin yung Hankinson's formula. Ayan. So ito yung ating situation number 4 na kinuha natin sa CE Board exam noong May 2015 for the structural engineering and construction. So don't forget to subscribe and hit the bell icon for the notifications and updates on our YouTube channel. So thank you for watching. Bye!